Hello, and welcome to today's lecture. As the title suggests, we will learn how to create scatter plots in Microsoft Excel. For today's demonstration, we will be using Excel 2010 for PC. Other PC and Mac versions utilize the same steps, however their layouts may slightly differ. Nonetheless, you'll be able to apply these steps to these different versions. Scatter plots themselves are important analytical tools and are utilized to examine the business value of investing in IT. We can look at sets of data graphically to examine how they relate to one another. Pairs of data between the two sets can be plotted as xy coordinates. Conventionally, the x variable represents the independent variable and the y variable represents the dependent variable. If a relationship exists between the sets of data, the individual data points will form a linear pattern. The stronger the relationship, the more the xy points will form a straight line. The relationship may be positive, that is, when the x-coordinate increases or decreases, the y-coordinate does the same, or negative. In this case, the x and y coordinates move in different directions. Overall, the strength of the relationship is measured from 0 to 1 and is represented by the letter R, the correlation coefficient, with 1 indicating a perfect relationship and 0 meaning no relationship exists. In the case of a negative relationship, the R value is qualified with a minus sign. Let's take a look at some data and actually use it to generate a scatter plot and look at the relationship between revenue and the investment in IT of our make-believe company. In this example, data was collected on an annual basis for 5 years. In the corresponding years, the amount of revenue that the company earned was calculated, as well as how many dollars were invested in IT. We start this process by selecting the cells containing the data that we want to analyze. Be careful not to grab the cells that include text or any other type of stray characters, as those characters will not be interpreted as numerical data. We then go to the headings at the top of the Excel spreadsheet and click on the heading that says Insert. This will bring up a ribbon of selections that allow us to insert different types of objects, tables, and graphs into our Excel spreadsheet. When we click on this and we look under the area for graphs, we'll see a graph box that says Scatter. Click on the downward arrow under Scatter and select the linear scatter option that appears. A common mistake for students is they accidentally select the line graph. Be careful that you don't do this. So with just a few clicks of the mouse, we're able to generate a technically accurate scatter plot. And although it is technically accurate, let's take the time to make this graph look nice and presentable. One of the first things you should notice is that there's a large blank space in the lower left-hand corner of the graph. We can get rid of this by reformatting the x-axis and the y-axis. What we'll do is we'll make the start points not be $0 for each axis, but we'll select a large enough dollar value that starts at the beginning of the smallest data point. In this case, for the x-axis, we'll start our graph somewhere around $100,000, and for the y-axis, we'll start our graph somewhere around $8,000. We reformat these axes by right-clicking on the numbers that make up either of the axes lines. When we do that, the Format Axis pop-up window will appear. Notice that under Minimum and Maximum, the radio buttons are selected for Auto. In order to reset these axes, we change the minimum value to Fixed. In the case of the y-axis, we select Fixed and then change the value to 8,000. For the x-axis, we select Fixed and change the value to 100,000. Here's what our graph looks like now that we've reformatted both our x and y axis. Notice that we've eliminated that large blank space in the lower left-hand corner. This graph looks much nicer and is much more presentable than the graph on the previous slides. However, notice we still have this one legend that's titled Series 1 appearing here. This legend is inappropriate and doesn't need to be here. This is a default setting in Excel. It can be useful sometimes when you're overlaying multiple graphs and represent different items. However, since we're plotting just one item, we can eliminate this. Here's what our plot looks like after I deleted the legend. I will caution you that when you make a formatting change to a plot in Excel, it's not uncommon for Excel to also automatically adjust your axes. Although I don't show it to you here, that's exactly what happened. In this case, the major tick marks for both the X and Y axes were changed so that the numerical labels overlapped and were difficult to read. I reformatted the axes by right-clicking on the axes values, just as we did earlier, and reformatted the major tick marks to make them look as you see them now. Now that we have a properly formatted scatter plot, we can insert our trend line. To start this process, click on the border area of the dot plot. When you do this, the Chart Tools section will appear at the top of the Excel page. Look for the Layout tab and select it. In the Layout tab, you'll see a button for Trend Line. Click on this button, and on the subsequent drop-down menu that appears, select the Linear Trend Line. When you do this, you'll create a trend line in your dot plot, and it should look something like this. Now that we have our trend line, we need to display the equation of the trend line and the trend line's R-square value. To do this, right-click on the trend line and select Format Trend Line. Notice on the dialog box that appears that the linear option is selected. Do not change this. At the bottom of the page, you'll see Display Equation on Chart and Displayed R-squared value on Chart. Make sure that the check boxes are selected and then hit Close. When we close the previous dialog box, we'll return to the Excel spreadsheet and we'll notice that within the dot plot, the equation for the trend line and the trend line's R-square value will appear. Let's talk about the R-square value briefly. Frankly, we're not interested in the R-square value. The R-square value is the coefficient of determination. It is the proportion of variability in a data set that is accounted for by the statistical model. What we're interested in is the R value, the correlation coefficient. And again, this measures the strength of the linear dependence between the independent and the dependent variables. Because we include an intercept in our equation, we can calculate the R value by taking the square root of the R squared. Doing so gives us an R value of 0.892. Now that we have our plot, our trend line, and our R value, let's make one or two more minor adjustments to really make our plot stand out and make it publication worthy. The first thing to do is to click on the outside periphery area of the plot and bring up our chart section at the top of the Excel page. And under the chart section, look for chart title and axis titles. Clicking on these individually, we'll be able to add a title to the plot and be able to label our axes so the readers of our data know exactly what type of data we're looking at. This is our final product. It's ready to go in either a poster or a peer-reviewed journal. I think you'll agree that it looks a lot better than what we first started with. In summary, Microsoft Excel is a useful tool for creating graphs from statistical data sets. Scatter plots are an important type of plot and are used to examine dependent relationships between data sets. And lastly, trend analysis reveals the coefficient of determination, or R squared, and this can be used to derive the correlation coefficient of R. And I will caution you on this last point that statistically speaking, this is only accurate when an intercept is included in your equation of your line. That's it for today's lecture. Thank you for your time and attention.